Welcome to Astronomy Daily, your daily dose of cosmic insights. I'm Anna, and I'm thrilled to guide you through today's exciting developments in space exploration. We've got a packed show for you, starting with ambitious new missions aiming to unravel the mysteries of Mars and the Sun. We'll also bring you the latest updates on Boeing's Starliner capsule, including its recent challenges and what's next for the spacecraft. Plus, we'll take a fascinating historical peek into the personal mementos carried aboard Apollo 11 by none other than Neil Armstrong himself. So let's dive right in. First up, let's talk about Mars and a fascinating proposed mission that could be a game changer for future human exploration of the red planet. It's called M-MATISSE, which stands for Mars Magnetosphere, Atmosphere, Ionosphere, and Space Weather Science. This mission is vying for a spot as the European Space Agency's next medium mission, with a decision expected by mid-2026. If it gets the green light, M-MATISSE would be the very first mission solely dedicated to understanding planetary space weather at Mars. Preparing to send astronauts to Mars means we need a really deep understanding of the conditions they'll face when they arrive. That's exactly what M-MATISSE aims to provide. The concept involves launching two robotic orbiters, aptly named Henri and Marguerite, to profoundly investigate Mars's atmosphere and surrounding environment. These two identical spacecraft, each carrying the same set of instruments, would observe the red planet simultaneously from two different locations in space. Henri would primarily explore within the Martian plasma system, while Marguerite would mainly operate in the solar wind and Mars's far tail, a region that's largely unexplored. Together, they'd probe several critical layers, including the magnetosphere, which is the region controlled by Mars's magnetic field, the ionosphere, a high-altitude layer filled with charged particles, and the thermosphere, where atmospheric gases escape into space. They would also examine conditions in the lower atmosphere and, crucially, monitor radiation accumulation. Dr. Beatrice Sanchez Cano, from the University of Leicester, who is spearheading this international effort, emphasizes just how vital this mission is. She explains that M-MATISSE will offer the first global characterization of the dynamics of the Martian system at all altitudes. This is crucial for understanding how the atmosphere dissipates incoming energy from the solar wind, including radiation, and how space weather impacts surface processes. This understanding is absolutely essential for safe exploration. It will lead to accurate space weather forecasts, helping to prevent hazardous situations for both spacecraft and human explorers on the red planet, much like how space weather monitoring on Earth protects our systems and astronauts. Beyond safety, the mission also promises to shed further light on Mars's habitability and the evolution of its atmosphere and climate. It will reveal how the solar wind influences Mars's atmosphere, ionosphere, and magnetosphere, and investigate the impact of these interactions on the lower atmosphere and surface. The UK is playing a leading role in the mission selection phase, particularly with responsibility for the Particle Instrument Suite, which will provide the most accurate observations to date of all particles at Mars, including neutrals, ions, and electrons. The UK will also be home to the mission's Science Centre, coordinating its scientific planning and data exploitation. So, M-MATISSE represents a vital step toward making human landings on Mars safer and more feasible by giving us an unprecedented look at its complex space weather environment. It's definitely a mission to watch out for. From understanding Mars, we now turn our gaze to our own star, the Sun, and an exciting upcoming mission set to unveil some of its deepest secrets. In July, NASA will launch the groundbreaking Solar Eruption Integral Field Spectrograph mission, or SNIFS. This mission, delivered to space via a Black Brant 9-sounding rocket, will explore the energy and dynamics of the chromosphere, one of the most complex and enigmatic regions of the Sun's atmosphere. The launch window for SNIFS opens today at the White Sands Missile Range in New Mexico. The chromosphere sits between the Sun's visible surface, or photosphere, and its outermost layer, the corona. While we've researched the Sun's atmospheric layers extensively, many questions about the chromosphere persist. As Philip Chamberlain, a research scientist at the University of Colorado Boulder and principal investigator for the SNIFS mission, put it, there's still a lot of unknowns. This layer is particularly important because it lies just below the corona, where powerful solar flares and massive coronal mass ejections, or CMEs, are observed. These dramatic solar eruptions are the primary drivers of space weather, hazardous conditions in near-Earth space that can threaten satellites and endanger astronauts. The SNFS mission aims to learn more about how energy is converted and moves through the chromosphere, ultimately powering these massive explosions. Understanding this process is vital for accurately modeling space weather and ensuring the safety of Earth and our space assets. What makes SNFS truly innovative is that it's the first ever solar ultraviolet integral field spectrograph. This advanced technology ingeniously combines an imager and a spectrograph into a single instrument. Imagers are great for capturing wide views and combined light, while spectrographs dissect light into its various wavelengths, revealing crucial details like element presence, temperature, and movement, but typically only from one point at a time. SNFS gives scientists the best of both worlds, pushing the limits of what technology allows us to do in solar observation. The mission will focus on specific wavelengths, known as spectral lines, particularly a hydrogen line that's the brightest in the sun's ultraviolet spectrum, along with two spectral lines from silicon and oxygen. Data from these lines will help scientists trace how solar material and energy move through the chromosphere, revealing how it connects with the sun's upper atmosphere. Sounding rockets, like the Black Brant 9, are efficient tools for launching space experiments and also provide invaluable hands-on experience for students and early career researchers. As Vicky Herda, a doctoral graduate who worked on SNFS, noted, "You can really try some wild things," emphasizing the unique learning opportunities these missions offer. The entire SNFS mission is designed to be incredibly fast, likely lasting only about 15 minutes from launch to landing. The sounding rocket will take about 90 seconds to reach space and point toward the sun, then perform its 7 to 8 minute experiment on the chromosphere before returning to Earth's surface in 3 to 5 minutes. It's expected to drift about 70 to 80 miles from the launch pad, landing safely in the vast, empty desert of white sands. After 4 years of dedicated work, the team behind SNFS, especially Herda, is immensely excited for this pioneering launch. From the exciting realm of solar observation, we now turn our attention to the more grounded, yet equally complex world of crew transportation to the International Space Station, where Boeing's Starliner capsule has hit a few snags. While the ISS has been a hub of activity lately, with various spacecraft coming and going almost constantly, Starliner has been notably absent from the schedule for the remainder of 2025. Starliner launched on its first astronaut mission, known as the Crew Flight Test, or CFT, in June 2024. It carried NASA astronauts Sunita Suni Williams and Butch Wilmore to the ISS for what was originally expected to be about a week-long stay. While Starliner had previously completed 2 uncrewed orbital flight tests, the CFT mission encountered unexpected challenges. On its journey to the space station, Starliner experienced multiple helium leaks, which were traced to components within its protective enclosures called doghouses. Additionally, 5 out of its 28 reaction control system thrusters failed in flight. These issues led to Williams and Wilmore's stay aboard the ISS being extended multiple times, while NASA and Boeing worked to troubleshoot the problems from the ground. Ultimately, out of an abundance of caution, the decision was made for Starliner to return to Earth without the astronauts aboard. Williams and Wilmore were then integrated into the ISS long-term crew rotation and returned to Earth months later aboard a SpaceX Crew Dragon, rather than the Starliner they arrived on. Since its uncrewed return in September, NASA and Boeing have performed extensive analyses of the issues within Starliner's doghouses. They've slated affected components for rigorous evaluation at NASA's White Sands Test Facility this summer. Steve Stitch, NASA's Commercial Crew Program Manager, explained that they are testing various materials to improve seals and prevent oxidizer vapor permeation, which was identified as a weakness. They are also performing pulse trains to cycle thruster burns at varying intensities and frequencies to better understand temperature swings within the doghouses. Improvements have already been made, including thermal modifications like adding a shunt and other barriers to prevent heat from radiating back into the thruster clusters. These tests are crucial for refining thermal models for an integrated doghouse test, which will simulate thruster firings to fully understand heat dynamics. As for when Starliner might make its way back to the launch pad, the timeline has shifted. NASA officials are now working toward a flight no sooner than early 2026. It's also very likely that Starliner's next launch will be an uncrewed cargo flight first. This cargo mission would allow them to fully test all the changes being made to the doghouses and validate them in flight before risking astronauts on board again. NASA remains committed to Starliner as a critical part of ensuring redundant access to low Earth orbit for the United States, a goal that even SpaceX is reportedly cheering on. Finally, today, let's take a look back at a truly historic moment in space exploration. For years, the contents of Neil Armstrong's personal preference kits carried aboard the Apollo 11 mission have held a certain mystique. These kits, known as PPKs, contained items that made the incredible journey to the moon. Now we have a clearer picture of what was inside. Detailed manifests of these personal items, which included various mementos intended for the mission's flight crew support team members, have been made public. These fascinating inventories are now housed at Purdue University, offering a unique and deeply personal glimpse into the souvenirs that traveled to the lunar surface. It's a wonderful way to connect with the personal side of such a monumental achievement. And that brings us to the end of today's Astronomy Daily. Thank you for tuning in. I'm Anna, your host, and it's been a pleasure sharing these cosmic updates with you. Don't forget to visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter to stay up to date on all the latest space news and become a true completionist by catching up on all our back episodes. By the way, if you do achieve that goal, let me know and I'll give you a shout out on the show. You can also subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. We look forward to having you join us again tomorrow. In the meantime, remember to keep looking up.